Welcome everyone. In this video I'm going to dissect this milling table. It's a relatively decent and reasonable milling table. It has quite smooth movement, but it's not the most precise thing on the earth. But we can improve this device a little bit, and in this video I'm going to show you what is this exactly and how we can improve it and what we can improve about this. So as you can see, this is the table and there are a few parts coming with it. So let's just go through those. So we have these bolts and nuts and this kind of metal plate to clamp down certain stuff on the surface of this working area. So yeah, we just take the nuts and the bolts and so on, and yeah, you just use like this. And then it also comes with this Allen key. I will show you how you use this, and there are two handles with the screws which can be used with these knobs for the X and Y directions. So this is all about the parts, and as you could see, I was able to slide this bolt here. So these channels are perfect for these kind of bolt heads, and we can fit it in very nicely, but I will show you this later. So we have the X-axis, and the travel distance of this is 20 centimeters, while the working area is 30 centimeters. So I can just measure it. So as you can see, it's 30 centimeters or 12 inches. And then in this direction, it's 9 centimeters wide, and the wall travel is 5 centimeters. So it's not a very big area, but for hobby projects and things like that, it's perfectly enough. So this is the Y-axis, and as you can see, it moves nicely and smoothly, and this is the X-axis, and there is no play in it, so it's not wobbling, quite rigid. So now I have to like grab it very strongly, but I still cannot feel any large play, and the reason is behind these 3 screws, basically here and also there. But before that, let's go back to the axis. So we have the X axis and the Y axis, and both of them have just a simple threaded rod. It's not even a lead screw, it's basically just a threaded rod. It's an M8 threaded rod, which also means that we can know the pitch of this. So one full rotation of this knob, both of these, will result in 1.25 millimeter of linear travel. So that's why I have to like screw or turn this thing a lot in order to move this table, and also here. So it's not very annoying on the Y-axis because that's like shorter, so I can move with this quite quickly, but then this is very long, 4 times longer stroke length than in the Y-axis, so it takes a lot of time to move. And in order to see how this works, I have to disassemble it. So I have to start with the X-axis part, so this table. So I removed this cap, and we have a nut here which is now revealed, and that nut is an 13 millimeter nut. So I just use a 13 millimeter key wrench, and I just simply remove it. So and the nut has a plastic thing, a plastic ring in it, which is used to hinder the nut unlocking itself. But we don't care about this right now, so I just have to unscrew this. So I reached the end, so I have to unscrew these 2 screws here. classical Phillips screw. So this is the metal part, which is at the end of this channel on both ends. And as you can see, there is a washer here, but there is no bearing. So there is already one thing that we can improve. So if you look at this, just very quickly check it. This is like 9 millimeter in diameter. Or let's just measure it properly with a caliper. So it's more like 8 millimeter, which makes sense because it almost perfectly fits the threaded rod. But yeah, this is just a washer, and on this side we have the cap and the nut. So it goes on like this, and this is some kind of cast metal, maybe aluminum. So let's remove this thing. And now we can reveal the secret of this thing. So the secret is this, which is a brass or copper plate. So it's in this notch here, as you can see. So it's here. And there are 3 screws here with the nuts on the other side. So we have this key here. So we can loosen or tighten these screws, or turn it so it will enter this part more. So then that will press this plate against the rail here. So when this brass plate is pressed against this part here, then that adds a friction, and it eliminates the slack as well. So when you press this against the rail or the metal body here, then of course you fill up the gap. So if there is any slack when these screws are not tightened, then you just tighten the screws and then fix them with the nuts, and there won't be any kind of wiggling motion. And then there is this copper part, which is just a simple nut with a cylindrical body. So this is how this moves. So you can see that the shaft is inside this nut, and when you rotate the nut, or when you rotate the shaft, then it will climb up in the threads of the nut, and it will push or pull this table back and forth. So that's how it works. So this is the x-axis. So yeah, this is the shaft and the copper or brass nut. And on the other side, we again here have the same metal part without any kind of bearings. So now we can remove the y-axis. I just clean up a little bit because it's greasy everywhere. So the same 13 millimeter nut. So just a rubber or plastic washer and a metal washer, and no bearings. So a plastic cover here, a small metal part here, but no bearings. This is the other end. And then the same thing. So we have this brass nut, same as here. And then a few plastic parts, they can slide on each other. And then of course we have the breastplate, which is here on the same side where you have the screws, which can be used to adjust everything. So I just removed this side and it's the same. So there's nothing extraordinary. This is, I think, a cast aluminum. I can check it. Yeah, it's not magnetic, so it should be some aluminum, and it's very light, so yeah. But this is the part which goes on your drill press, on the base plate of it. So you can screw it on the base plate, and then you can adjust it. I will include a picture of my drill press with this thing mounted on it. So let's measure a few things, just a few lengths, which might be useful for us. So this is the y-axis screw. So let's measure the lengths of it, the exposed lengths, let's say. Just a rough measurement. So the length of this is 16.5 centimeters without this knob. But if I try to measure it with the knob, then it is about 19 centimeters. And if we have the x-axis, this guy here, then it is about 31.7 centimeters, so roughly 32 centimeters, and then 34.5 from here to here. And as I said, this is an M8 thread with a 1.25 millimeter pitch. Yeah, it's 8 millimeters, and then the pitch is 1.25. So once again, if I put it down like this, and then I do a full rotation of this thing, and I rotate it in clockwise, then the thread or the threaded rod will advance 1.25 millimeters in this direction. And if you turn it counterclockwise, then it will go in this direction by 1.25 millimeters. So why I disassembled this thing is to show you how it looks like from the inside and to show you the main principles of this very simple device. And also I want to improve this or make it a bit more useful for me or for you. So therefore we should go through this thing, what can be improved. So as you could see on these parts, we don't have any bearings. And it's not like that it is missing from this thing, because it's so simple, or it's so simplified that it might not add too much to this if we add bearings. But still, we can add bearings, so why not add? So I thought about two options. One is this. It's a flat bearing, this KP type of bearing, and this is 8 millimeters, so this should go in it. So what we can do is that we can align the bearing with this hole, and then as you can see, we can drill 2 holes here and there. So what can be done is that we put this bearing on this, and then drill the hole, and then just use a few bolts and nuts, and then just fix this thing on it. But adding this bearing on both sides might need a bit longer screw, because if we check this and look at this, then we can see that the screw is not sticking out too much. So if I add this bearing on this side, then the screw doesn't come out, which is a problem. And if I add the bearing on the other side as well, then it becomes even shorter, and then that's like a real problem. But luckily I have a 1 meter of this exact type of shaft, so I can replace it. But then comes the problem that I lose this knob. As you can see, they used some kind of permanent way to fix it in the knob, so we lose this. But that might not be a big problem, because I have some other plans where I don't really need this knob. But let's talk about that plan a bit later, because I still have some things to show you. So another option for the bearings, this is a truss bearing, so it is accounting for the axial forces, but as you can see, this is smaller in diameter, and I haven't tested this, but as you can see, it almost perfectly fits in this hole. So I might use a vise or something and just press it in, and then I add this, and then add this, and fix it. And then we can do another thing as well. So I have the other type of the bearing, which is the radial bearing. So it does not account for the axial forces, which we need more maybe, but at least we can put it here. And then the inner diameter of this bearing here, so the diameter of this cylinder is 16 millimeters, and it happens to be the same as the diameter of this inner part, so which is the deepest part of this structure. So if I drill a 16 millimeter hole here, then I can actually push this in and sort of hide it, and then I can put the bearing of this or the washer of this bearing here, which will be supported by this edge here, and then put the bearing bolts there, and finally put the other washer on top of it. So then I would not extend it too much in height, and I would have a bearing which would help to center the shaft, and I would have another bearing which would help to keep the axial forces in control. So I might try that, and I might destroy everything, but it's worth a try. So I will drill this hole and I will show you the results. So I'm back with the result. It's this one. So I enlarged the hole. So this is like 8 millimeters roughly, the hole size. And then this is supposed to be 16, so double in diameter. And then we have this bearing, so it's a radial bearing. So now you can see that it fits. So what I will do, I put the screw here, or the bolt here, and then I put a washer here. I can actually show it. To make it fit tightly in the hole, we have this here, and then the washer goes here. I just have to make sure that the washer sits on the body, on these edges, and it will not fall in. So now I will just get 2 wrenches and then tighten it. So that will make sure that the bearing will be fully inserted and it will be supported by the flange around it. So I will do that and then I return and show the next step. So if I want to do it properly, I should do this for all these things. And in fact, I have enough bearings for both types, so why not? So now I have all these blocks drilled out. In fact, I went for the y-axis as well, so now I can insert the bearing in those blocks as well. So we should assemble this thing, and before that I just want to mention something. So these are only radial bearings, but then we also have thrust or axial bearings, these sandwiched things. And what we can do is that we can use both. In fact, the use of the thrust bearing would be also nice, because if we move something, let's say heavy, then there is an axial force. But the axial forces here are not too significant, so we might skip it. But if you have to add these, or want to add these, you have to be aware that the length of these screws are not sufficient, because you add the bearings and then you add 6.5 millimeters, the thickness of this thing, to both sides of the screws, to this Y screw and also to the longer X screw. And that means that at the end, where you should put on this locking nut, you won't be able to put it because of the additional length. Your screw will be somewhere here, so it will not reach the end of this block. So therefore, what I just use is this radial bearing and then the original washers, both the plastic and the metal. So now what we have to do is we have to assemble it, and I try to show you how to do it. So if you haven't destroyed your plastic things like I did for this, then this has like a J shaped or hook shaped plastic part, and that plastic part grabs this metal thing like this. So you can see that it sits in that, and that should come here on the end or at the end of this. And now you can use this, and it should this thing points upwards. Then you can screw this on. So you just have to find where it is, and you can fix one side of this table. So I just fixed this roughly, and then we carry on with the rest. I left the screws a bit loose if we need some adjustments. So this is the other, and you can see the difference between the side one and the middle one. So the middle one has these lines here, and there is a ledge here which grabs this part of the block. And also there is a ledge in the inside, or on the inside, which grabs the ledge of this. So if I put this here and I slide it, it stops here. So what we need to do now is we put this block on top of this rail without this copper part. So I just slide it on. So I can lift this block and put it over this plastic part like this, because now I just demonstrate this to you, that if I pull this block, then it will pull the plastic with itself, because the plastic has that ledge which grabs into this block. So that's how it moves this cover back and forth. So we just put this together, and a very important thing which actually happened now is you have to make sure that the nut stays inside this thing. So you just try to align it, and in fact when you put this together, this nut is basically touching this plate here. So you will see it. So this part is assembled, and now it's sitting tight on this, except we don't have this stick. So I just insert it, and you have to make sure that these screws are all the way out from this block, otherwise they can block the stick. But you can see that I can push it in all the way. So now we go to this side almost entirely. You cannot or you should not go all the way, because then this plastic cover will fall into this part, and then you have to disassemble everything. So now this can go under it like this, and then this can go under the other plastic part. So now they are assembled, and since I lost those hooks, then this will move as well, but for you there should be two hooks, so you can put this metal part over that hook, so it should stay there, but you see it falls out. So what I do, I just put this metal part into this block and try to assemble it. So I just insert the screws. So this is done, but as you can see, due to the missing hooks, this will slide as well, but I don't care at this moment. So this is almost done. The washers are on this, so I put on the bearing, and then I try to find the hole on the nut. So we found it. And then before reaching the block, I put in the other bearing. And it's there. So I put on this washer, and the metal one. And the locking nut. So now, after putting this together, you can see it moves, but there is a slight play sideways. So I have to start to tighten the screws on the side of this block. So they will push this strip against the side of this block, which results in a much smoother movement. And you should not tighten them too much, so just gently, little by little. So there is no play now. And you see, this goes back because nothing holds it down due to the broken hook. But I don't care about that right now. It's an acceptable loss. So this moves, and I feel it's smooth enough. So now we put on the x-axis, the longer part, and I skip this for now, and I just slide the body on. And before doing that, you have to make sure that you have the nut inserted. And then this face is upside or upwards. You can see the channels. So we have the bearing in, so just a few screws. And also what you should check this or check here is this knob is facing you, so you have to make sure that the scale also faces you. So I'm just trying to warn you that don't miss that part. So then this is the other block. And in fact now you can do a nice thing. So if you are left-handed, then you can put the knob here, or if you are right-handed, you can put it on the other side. So this is also why you should be able to disassemble it and reassemble it, because then you know what is inside, and then you can also sort of customize it to your own needs. So I'm right-handed, so I insert the screw from this side. So again, metal washer, plastic washer, and the bearing. But in fact, I think we can skip the plastic one. So we reach the other side. That's very nice. So we have the metal washer goes on, and then the nut goes on. And if the nut starts to rotate because the nut is too long because of the bearings, then you can put it on the other way around. So starting with the plastic part, so you put on it like this. But this moves, and you can see that we have the play because I haven't inserted this, but now I can do it. And this is, you can see it's slightly off-centered on this axis, so this should be on the bottom, so you should insert it yeah, like this, and this should face the middle screw here. So I tighten these three screws here, and then I tighten the nuts, and I eliminated the play on this direction. So it's restored, and now it's aligned to the middle, still works. As you can see, I added this handle. You can add it to both axes. So you take this metal part, slide in the copper colored nut, or bolt, sorry, and then you find a hole, and you just need a screwdriver. And now you have this crank. So basically this was the first part of the demonstration. I will have a second video on this, and what I will do is I will make this into a stepper motor controlled milling table. So we will put a stepper motor on the y-axis and also on the x-axis. I will replace the screws. I will add the truss bearings, and I will add 2 stepper motors to each axis, 1 and 1. So that will be nice, because then it will be a numerically controlled milling table. So I will implement it with an Arduino and some stepper motor controllers and some buttons and display, so we will see the displacement on the X and the Y axis based on the steps done. I will not add encoders because they are very expensive for this kind of table, so we just calculate the displacement based on the number of steps done. So that will be the second part. So in this part I just wanted to show you this very nice table. Actually, for this price, it's a quite decent table. I haven't found any flaws or problems with it. Yeah, it doesn't have bearings, and the plastic things could be a bit better because they are very fragile, but no one told me to disassemble it, so it's my fault. But yeah. So as you can see, this is a very decent table. It moves very nicely, and it's very easy to disassemble it. If you need to grease these channels here, or if you want to add some stuff, that's very easy to do. And as you can see, we can improve this. So yeah, the next part, I will figure out how to make it compatible with the stepper motors. And once I'm done with that, I will also add the screws, add the motors, the electronics, and show you the final product. So I hope you learned something, and I hope that this kind of video was useful, especially if you want to buy this product. Then you can see all its parts, and you see how to disassemble and reassemble it. So yeah, that was the intention, to show you this thing inside out. So yeah, once again, in the next video, we will make this into an electronic milling table, and we will enjoy it, hopefully. So I hope this video was useful. I hope you learned something, and see you in the next video.